Now let's look at how the position of the sun, the moon, and the earth create eclipses. So the sun creates the light, and the earth or the moon are going to create a shadow. And depending on which is going through the shadow depends on if it's a solar eclipse or a lunar eclipse. And the position you see in this illustration, we have the perfect alignment for a solar eclipse because the moon creates a shadow onto the earth. A lunar eclipse is created when the moon passes through the earth's shadow. So it's the opposite effect. So let's take a closer look at how each of these works. This illustration shows 4 different perspectives of what goes on between the sun, the earth, and the moon. So in this top illustration, we can see that the earth is spinning around, and that does it every single day. And in this illustration, you can see the earth slowly making its way around the sun. So the sun's creating the light shines over here, and it also shows the moon as it goes around the earth. This perspective down here shows how the moon is going around the earth and while the earth is spinning. And then up here on this perspective, we have what the phase of the moon is going to look like with the sun hitting the light of the moon and reflecting back towards the earth. So let's start out with a new moon. And a new moon is going to start right about here. So on the new moon, you can see here that the light from the sun hits the moon, and notice that all the light that's hitting the moon is getting reflected straight back to the sun. So none of the light is reflected back towards the earth. So that's why we don't see a moon, and it's called a new moon. And then here's another perspective. The light's coming in this way. It hits the moon. All the light's reflected back, so we can't see the moon. Or if we see the moon, it's very, very thin. Let's continue on to the first quarter. So what happens with the first quarter? The moon continues to move, and as the moon is continuing to move, here's our first quarter. The moon now is in this location over here. So now the sunlight is going to come across, hit the moon. It's some of it's going to reflect back into outer space, but half of that light is going to be reflected back to the earth so that we see this view from Earth, and it looks like it's a quarter of a moon. So here we can see here the light from the sun is going in this direction. It hits the moon over here, and we can't see the light that's reflecting this direction, but we can see the light that's reflecting in this direction. Now let's go ahead and look and see what our full moon is going to look like, and our full moon is going to be about right here. And so as you can see, the light is going to come off of the sun. It's going to go hit the moon on the other side of the earth, reflect back, and almost pretty much all the light that hits the moon is going to be reflected back to the earth. Here's our other perspective. Comes down, we see the moon, that hits the moon, reflects back, and when we look up at the night sky, that's when we see a full moon. So during these situations, that allows us to see certain shadows. Each time, now on a full moon, the earth is creating a shadow on this direction, and sometimes the moon passes through the shadow, and that creates a lunar eclipse. However, when we have the moon passing in front of the earth, the moon creates a shadow, and when the shadow goes through the earth, that's when we see our solar eclipse. Here is a video of a lunar eclipse that occurred April 4th, 2015. This is about a 4.5-hour event that is time-lapse, so that way the 4.5 hours been condensed down to 1 minute. So as you can see here, this is the shadow of the earth. So the moon is passing through the shadow of the earth, completely encompassing it. And so now as the moon passes into the shadow. So the moon becomes eclipsed, and sometimes you get this red glow from the moon because red light sometimes gets refracted around the Earth, and then the moon comes out and merges out the other side, and so this is the edge of the shadow of the Earth, and the moon emerging out the other side. And notice that this only occurs during a full moon. I'm sure all of you have heard in school at some point in time that the sun is huge. It's really big. And the moon, although it's kind of big, it's not nearly as big as the sun. However, when you look at them side by side, just like in this picture, they appear to be about the same size. So why is that? Well, it has to do with perspective, and it has to do with how close the moon is to the Earth compared to the sun, and how the geometry and the angular diameter that both of them make happen to be identical because of their distance from the Earth. So first off, let's compare the size of the sun with the size of the moon, and we're going to just take a ratio because it might be easier to understand how all of this works if we understand ratios. So here we have the sun with a diameter of 1,392,000,000 kilometers, and that would be 1,392,000,000 kilometers, and we're going to divide that by the diameter of the moon, which is only 3,478 kilometers. So that would be divided by 3,478 kilometers. When you take out a calculator, you'll discover that the answer is approximately 400. So that means when we say 400, that what we're saying is that the sun, the diameter of the sun, is approximately 400 times the diameter of the moon. But we also have to take into account distance. So let's look at distance. Now let's look and see how distance plays into our equation. So what we're going to do is we're going to take the average distance between the Earth and the sun, because it's going to be about the same distance between the moon and the sun also, because the moon goes around the Earth. So what we'll use is this number, 149,597,870 kilometers. And we're going to divide that by the relative distance between the Earth and the moon, which is 384,800 kilometers, which is going to give us 389. And that is our relative perspective. Now remember, before we had a number of 400. So we have 400 as the relative size between the sun and the Earth. And now we have a relative distance of 389. That means that the sun is about 389 times further away from the Earth than the moon is. The two numbers are not exact, but they're very close, which is why they look to be about the same size in the sky. Photographers can get the same effect by placing smaller objects closer to the camera than the larger, farther objects. So in this example right here, the hand appears to be about the same size as the Eiffel Tower, but in reality, the hand is much, much smaller. And in some of the others, you can have a girl look like she's kissing the Sphinx, or a small bucket looks like it's so big that it could encompass a mother and child, or somebody's foot that is just as big as the Stonehenge and about to crush it. So these are all due to perspective and the fact that the smaller object is closer to our view, and so therefore appears much bigger. And so that's how the sun and the moon appear to be the same size.